All right, welcome to The Explainer. In this one, we're going to follow the wild, high-speed journey of a single piece of data as it just zips across the entire internet. So let's dive right in. You ever stop and think about what actually happens when you click a link? I mean, your request flies to a server maybe thousands of miles away and comes back all in the blink of an eye. It really does feel like magic, doesn't it? But it's not magic. It's just a really, really clever system. So, the secret sauce here is something called the network layer. The best way to think about it, it's like the internet's own global postal service. Its entire purpose, its only job, is to get your data, your digital letters, if you will, from your computer to its destination. And you don't have to worry about all the crazy complex stuff in between, all the sorting offices and delivery routes. It just works. Okay, so for any postal service to work, you need one crucial thing, right? Every letter needs an address. And guess what? The internet is exactly the same. And that address, well, that's the famous IP address. You've probably seen these strings of numbers around. This is it. This is the unique destination that gets stamped on every single little packet of data that goes anywhere on the internet. What's cool is that an IP address is set up pretty much just like a regular old mailing address. The first part, the network part, you can think of that as the city. And the second part, the host part, that's like the specific street address. It's this two-part structure, this hierarchy, that lets all this data get routed so incredibly fast. Now, this is a really key point. An IP address doesn't actually belong to your computer. It belongs to your computer's connection to the network. Think about it. If you take your laptop from your home Wi-Fi and go to a coffee shop, boom, it gets a totally new IP address. It's just like moving to a new city. You've got to get a new mailing address. Okay, so our little data packet has its address. Now for the big question. How does it find its way through this massive, complicated maze we call the internet? Well, it does it using these things called routers. And if the network layer is our giant postal service, then routers, they're the individual postal sorting offices. These things are the absolute workhorses of the internet. We're talking millions of decisions every single second. And a router's job is actually pretty straightforward. It follows a simple process called store and forward. So first, it gets a packet and stores it for just a microsecond. Then, it looks at the destination IP address on the packet. It checks its own internal map, that's called a routing table, to figure out the best next stop. And finally, it forwards the packet onto the next router in the chain. And this happens over and over and over again, hop by hop, at almost the speed of light. So this system, it worked perfectly. For decades, it was great. But then, a problem started brewing. A really big one. The internet was literally running out of addresses. See, the original system, which we call IPv4, it had around 2 billion usable addresses. Now, back in the 1980s, that number sounded, well, it sounded infinite. I mean, who could possibly ever use up 2 billion addresses? Turns out, we could. But wait a second. With billions of addresses, how on earth did we start running out? Well, the problem wasn't really the number of addresses we had. It was all about how we were handing them out. The old system used these really rigid classes. So you could get a Class A block, which gave you almost 17 million addresses. Way too many for any single company, right? Or you could get a Class C block with just 254 addresses, which a growing company would outgrow in no time. This terrible mismatch led to incredible waste. Millions and millions of addresses were assigned, but just sat there, unused, creating this completely artificial shortage. And this chart, this shows you the real-world consequences. It's not theoretical. Starting in 2011, the official groups that hand out IP addresses just started running dry. The Asia-Pacific region went first, then Europe, then Latin America, North America, and by 2019, every single major region in the world had used up all of its available IPv4 addresses. They were gone. Okay, so the sky is falling, right? Well, not quite. The internet's engineers, thankfully, are pretty smart people. They saw this crisis coming from a mile away and came up with some really clever fixes to make the whole system way more efficient. The first big idea was something called subnetting. This is a technique that lets network admins take a big chunk of addresses and slice it up into smaller, more efficient subnetworks.
If we go back to our postal analogy, this is kind of like adding zip codes inside a big city. It just makes everything much more organized and manageable.
And that idea led to a whole new, much more flexible way of writing down addresses. So instead of those old clunky classes, we now use this notation right here. It's called CIDR. That's CIDR, which stands for Classless Interdomain Routing. And CIDR is a total game changer because it completely throws out that old wasteful class system. You see that little number after the slash? That number tells routers exactly how many bits are in the network part, the city part of the address. This lets us create network blocks of pretty much any size we want, perfectly tailored to a company's needs. All that waste from the old system? Gone.
Now, subnetting and CIDR, they were brilliant. They were like super strong duct tape that held the internet together and kept it growing. But they were still just patches. They couldn't solve the fundamental problem forever. We needed a real long-term solution.
And that long-term solution is called IPv6. Just look at this comparison. The number of new addresses it gives us is, well, it's staggering. It's a number so big it's hard to even wrap your head around. IPv4 had about 4 billion addresses. IPv6 has 340 times undecillion. That's a 340 with 36 zeros after it. To put it simply, we're never running out of addresses again. Ever.
So IPv6, which just stands for IP Next Generation, was really designed with one main goal: to make absolutely sure the internet had room to grow basically forever. We're not just talking about computers and phones anymore, but connecting billions and billions of other devices in the future.
And, you know, IPv6 brought a lot more to the table than just a ridiculous number of addresses. It actually simplified the data packets so routers can process them faster. It built security right into its core instead of as an afterthought. It's way better at handling things we do all the time now, like voice and video calls. And it was designed to be extensible, meaning it's ready for technologies we haven't even invented yet.
So there you have it. From a simple click to a crazy journey hopping between routers and across networks, our little data packet has made it. It has arrived at its destination, all thanks to a system that has had to constantly change and evolve to keep up with our demands.
So the journey of this one packet is complete. But the bigger story of internet addressing, that's really just getting started. With the practically infinite space that IPv6 gives us, we're walking into an era where pretty much everything, your watch, your car, your refrigerator, your toaster, can have its own unique address on the global internet. So what does a world like that actually look like? That's a great question for another explainer. Thanks for joining us.